penicillin antibiotics. The discovery of penicillin represents one of humanity's greatest accidental breakthroughs. In 1928, Alexander Fleming noticed something extraordinary. A mold contaminating one of his Petri dishes had created a bacteria-free zone. This simple observation would eventually save millions of lives. What makes penicillin truly remarkable is its mechanism of action. Think of bacteria as tiny buildings with walls. Penicillin works by preventing bacteria from building their cell walls properly, essentially causing them to burst open and die. It's like sabotaging the construction of a building at its foundation. The most profound aspect of this discovery wasn't just penicillin itself, but how it opened the door to the entire field of antibiotics. It showed us that nature had already developed weapons against bacteria over millions of years of evolution. Scientists just needed to find and refine these natural defenders. However, the story of penicillin also teaches us about the constant arms race between medicine and disease. Just as humans learned to use antibiotics, bacteria evolved to resist them. It's a powerful reminder that medical discoveries aren't one-time solutions, but ongoing challenges requiring continuous innovation. The legacy of penicillin extends far beyond treating infections. It showed us how seemingly insignificant observations, when properly investigated, can revolutionize medicine. It's a testament to the power of curiosity and the importance of keeping our minds open to unexpected discoveries. Vaccination immunization. Vaccination represents humanity's greatest triumph over infectious diseases. The concept is brilliantly simple, yet profound. Train the body's immune system by introducing it to weakened or dead versions of diseases, creating an army of defenders before the real threat arrives. This discovery fundamentally changed our relationship with disease. Instead of just treating illnesses, we could prevent them entirely. It's like teaching the body's immune system to recognize and remember its enemies before they attack, creating a biological memory that can last a lifetime. The development of vaccines has led to the eradication of smallpox and the near elimination of polio, diseases that once terrorized humanity. It's equivalent to removing entire chapters from the book of human suffering, preventing countless deaths and disabilities before they could occur. Modern vaccination technology has evolved far beyond its early days. Today's vaccines can protect against multiple diseases simultaneously, be delivered through various routes, and even help fight certain types of cancer. It's like having a sophisticated defense system that can be programmed to fight specific threats. The impact of vaccination extends beyond individual protection to create herd immunity, where enough vaccinated people in a population can protect those who can't be vaccinated. It's a beautiful example of how medical science can create collective protection through individual actions.
Click subscribe to this channel to get more topics you love.
X-ray imaging. X-ray imaging marked the first time in human history that we could see inside the living body without cutting it open. When Wilhelm Röntgen discovered these invisible rays in 1895, he opened a window into the human body that would forever change medical diagnosis. The genius of X-rays lies in their ability to pass through soft tissue while being blocked by denser materials like bone. It's like having a magic light that can selectively illuminate the skeleton while leaving everything else in shadow. This simple principle has saved countless lives by allowing doctors to diagnose fractures, detect tumors, and identify various diseases. What makes X-ray technology particularly remarkable is its evolution. From simple black and white images of bones, it has developed into sophisticated systems like CT scans that can create detailed 3D images of any part of the body. It's like going from a simple shadow puppet to a high-definition 3D movie. The discovery of X-rays also led to broader applications beyond medicine. From airport security to studying the structure of crystals, these invisible rays have become essential tools in many fields. It's a perfect example of how a medical discovery can transcend its original purpose. The development of X-ray technology also teaches us about balancing benefits and risks in medicine. While X-rays can be harmful in large doses, learning to use them safely has allowed us to harness their benefits while minimizing their dangers. DNA structure discovery. The discovery of DNA's double helix structure in 1953 by Watson and Crick, building on the work of Russell and Franklin, is like finding the universe's most elegant instruction manual. This twisted ladder, with its four-letter alphabet of A, T, G, and C, contains the complete instructions for building and operating every living thing. What makes this discovery particularly profound is how it unified our understanding of life. From the simplest bacteria to the most complex human, all living things use the same basic genetic code. It's like discovering that every book in the world is written in the same language, just with different combinations of words. The structure itself is a masterpiece of natural engineering. The double helix design allows DNA to be incredibly stable, yet easily unzipped for replication. The complementary base pairing A with T, G with C ensures accurate copying of genetic information, like having a built-in proofreading system. Understanding DNA's structure opened the door to modern biotechnology. It gave us the ability to read, write, and edit the code of life itself. This has led to breakthroughs in everything from medicine to agriculture, fundamentally changing how we treat diseases and produce food. This discovery also revealed our deep connection to all life on Earth. By showing that all living things share the same genetic language, it provided scientific proof of our common ancestry and our place in the great tree of life. Anesthesia. Anesthesia represents one of medicine's greatest gifts to humanity, the ability to perform surgery without pain. Before its discovery in the mid-1800s, surgery was a horrific experience that many patients didn't survive simply due to the shock of pain. The development of anesthesia works like an off switch for consciousness and pain sensation. It's as if we found a way to temporarily disconnect the mind from the body's pain signals, allowing surgeons to perform delicate procedures while patients rest in a controlled sleep. What makes anesthesia particularly remarkable is its precision. Modern anesthetic drugs can be carefully controlled to maintain exactly the right depth of unconsciousness for exactly the right amount of time. It's like having a dimmer switch for consciousness that can be adjusted moment by moment. The impact of anesthesia extends far beyond pain control. It allowed surgery to develop from a crude last resort into a sophisticated healing art. Surgeons could take the time needed to perform complex procedures, leading to the development of modern surgical techniques that save millions of lives. Perhaps most fascinating is how anesthesia has helped us understand consciousness itself. By studying how these drugs work, scientists have gained valuable insights into how the brain creates awareness and processes pain. Insulin. The discovery of insulin in 1921 transformed diabetes from a death sentence into a manageable condition. Before insulin, a diagnosis of type 1 diabetes meant certain death, usually within a year. The ability to isolate and produce this hormone represents one of medicine's most dramatic life-saving breakthroughs. What makes insulin remarkable is its precise role in the body. Think of it as a key that unlocks cells, allowing them to absorb glucose from the blood. Without this key, cells starve while surrounded by abundance, like being in a room full of food, but unable to open any packages. The development of insulin therapy shows the power of scientific collaboration. From the initial discovery by Banting and Best to the later development of synthetic insulin through genetic engineering, each advancement has made treatment more effective and accessible. Perhaps most impressive is how insulin production has evolved. From the early days of extracting it from animal pancreases to modern methods of producing human insulin using bacteria, it shows how medical science can continuously improve its solutions. The story of insulin also highlights the ongoing challenge of making life-saving medications accessible to all who need them. It reminds us that medical discoveries must be paired with effective distribution systems to truly impact global health. Blood groups transfusion. The discovery of blood groups revolutionized medicine by solving a deadly mystery: why some blood transfusions saved lives while others proved fatal. When Carl Landsteiner identified blood types in 1901, he essentially created a biological matching system that made safe transfusions possible. Understanding blood types revealed an incredible truth about human diversity at the molecular level. It's like discovering that humans come in different editions, each with specific compatibility rules. The ABO system, with its precise patterns of antigens and antibodies, works like a sophisticated lock and key mechanism. What makes this discovery particularly fascinating is its practical application in emergency medicine. Blood typing and cross-matching have become routine procedures that save countless lives daily, but it's transformed major surgery from a high-risk gamble into a calculated procedure with predictable outcomes. The impact extends beyond traditional transfusions. Understanding blood compatibility has enabled organ transplantation, plasma treatments, and even helped us understand pregnancy complications. It's like having a compatibility chart for the human body's most vital fluid. Modern blood banking, a direct result of this discovery, represents one of medicine's greatest logistical achievements. It's created a system where life-saving fluid can be collected, stored, and distributed precisely where and when it's needed. Germ theory of disease. The germ theory of disease, pioneered by scientists like Louis Pasteur and Robert Koch, completely transformed our understanding of illness. It revealed that many diseases are caused by microscopic organisms, a discovery that shifted medicine from superstition to science. This theory was revolutionary because it provided a clear, observable cause for many diseases. Instead of blaming illnesses on bad air or evil spirits, doctors could now identify specific pathogens. It's like finally being able to see the invisible enemy that had been attacking humanity throughout history. The practical applications were immediate and far-reaching. Understanding that germs cause disease led to basic hygiene practices in medicine, such as hand washing and sterilization. These simple changes dramatically reduced death rates in hospitals and during childbirth. This discovery also gave us weapons against disease. Once we could identify specific pathogens, we could develop targeted treatments. It's like having a precise map of your enemy's weaknesses, allowing for more effective counterattacks. The legacy of germ theory continues to evolve as we discover new pathogens and understand more about how they interact with our bodies. It remains the foundation of modern infection control and disease prevention. Human genome sequencing. The completion of the Human Genome Project in 2003 gave us the first complete readout of human DNA, all 3 billion letters of our genetic code. It's like finally having access to humanity's complete instruction manual, written in a 4-letter alphabet of A, T, G, and C. This achievement revolutionized our understanding of human biology. It revealed that humans have far fewer genes than expected, about 20,000, instead of the predicted 100,000, showing that complexity comes from how genes interact rather than just their number. It's like discovering that a relatively small vocabulary can create an infinite number of meaningful sentences. The genome sequence has transformed medicine into a more personalized science. By understanding genetic variations, doctors can predict disease risks and tailor treatments to individual patients. It's like having a genetic crystal ball that can help guide medical decisions. This knowledge has sparked a revolution in treatment approaches. From cancer therapy to rare disease diagnosis, genetic information is becoming increasingly crucial in medical decision-making. It's opened the door to precision medicine, where treatments are matched to a patient's genetic profile. Perhaps most profoundly, the genome sequence showed that all humans are 99.9% identical at the DNA level, scientifically undermining the concept of biological races. It's a powerful reminder of our shared humanity. MRI magnetic resonance imaging. MRI represents one of medicine's most sophisticated windows into the human body. Unlike X-rays, which use radiation, MRI harnesses the natural magnetic properties of water molecules in our tissues to create detailed images. But it's like having a magical camera that can reveal the body's internal structures in extraordinary detail. What makes MRI particularly remarkable is its versatility. It can create clear images of soft tissues that other imaging methods struggle to show. Think of it as having different pairs of glasses, one for seeing bones, another for muscles, and yet another for brain tissue, all in one machine. The technology behind MRI demonstrates the beautiful intersection of physics and medicine. By using powerful magnets and radio waves, it can temporarily realign the water molecules in our bodies, creating signals that are transformed into detailed images. It's like choreographing a microscopic dance of molecules to reveal our inner structures. Perhaps most importantly, MRI has revolutionized our understanding of the brain. It allows us to see not just the brain's structure but also its activity in real time through functional fMRI. This has opened new frontiers in neuroscience and psychology, helping us understand how thoughts and emotions manifest in the brain. The development of MRI continues to evolve, with newer machines offering more detailed images and faster scan times. It's become an indispensable tool in modern medicine, guiding everything from surgical planning to disease diagnosis. Heart transplantation. The first successful heart transplant in 1967 by Dr. Christiaan Barnard marked a turning point in medical history. It proved that the most symbolic of human organs could be replaced, challenging our notions about the boundaries between life and death. The complexity of heart transplantation makes it a testament to human surgical skill and medical innovation. It's like conducting an intricate symphony where timing, technique, and teamwork must be perfect. The procedure requires not just replacing the organ, but reconnecting all the major blood vessels and ensuring the new heart starts beating in its new home. What makes heart transplants particularly fascinating is the challenge of rejection. The immune system naturally fights against foreign tissue, requiring careful matching of donors and recipients, plus lifelong medication to suppress immune responses. It's like convincing the body to accept a new member into its cellular family. But the development of transplant medicine has also raised profound ethical and philosophical questions. Who should receive donor hearts when they're in short supply? How do we define death in the context of organ donation? These questions have helped shape modern medical ethics. The success of heart transplantation has paved the way for other organ transplants and encouraged research into artificial hearts and tissue engineering. It stands as a symbol of how far medical science has come and hints at future possibilities. Birth control pill. The introduction of the birth control pill in the 1960s didn't just prevent pregnancy, it revolutionized society. For the first time in human history, women had reliable control over their fertility, separating sexual activity from reproduction in a way that transformed social relationships and women's roles in society. The science behind the pill is elegantly simple yet profound. By using synthetic hormones to mimic pregnancy, it prevents ovulation through the body's own regulatory systems. It's like having a master switch that can temporarily and reversibly turn off the reproductive system. What makes this discovery particularly significant is its broader impact on medicine. Research into hormonal contraception has enhanced our understanding of endocrinology and led to treatments for various hormonal disorders. It's like having a key that unlocked multiple doors in medical science. The development of the pill also represents a triumph of persistence over opposition. Its creators faced significant social and religious resistance, yet they persevered because they understood its potential to improve women's lives. This story reminds us that medical advances often require challenging social norms. The birth control pill sparked a revolution in reproductive rights and family planning that continues to influence global health and social policy. It's a powerful example of how a medical discovery can catalyze profound social change.